The objective of the assignment 2 is to compare the area of a given water body in the Open Series map generated in 2005 with that in a recent satellite image. Each student in the class is provided with a pair of image data and the name of a water body for analysis. Students can download the data by clicking the link provided to them. An image thumbnail is also provided to help easily locate the proposed water body within the image. There are a total of 5 evaluative tasks in the assignment. Task 1 is to georeference the Open Series map. For that, we need to open the QGIS and load the OSM map. Open the new empty project and go to the Layer menu in the top toolbar. Select Add Layer, Add Raster Layer. Click Browse to find the location of your OSM map file. Select the file and click Open. Once the image is selected, click Add to load the image into your QGIS project. The OSM map will appear in the map view on QGIS. Georeferencing a map in QGIS involves aligning a raster image with geographic coordinates. This can be done by assigning control points and transforming the image to fit a spatial coordinate system. For that, we shall click on Layer and then Georeferencer. In the Georeferencer window, click on Open Raster and select the map file you want to georeference. The map will now be displayed in the Georeferencer window. All 4 corners of the map show latitude and longitude values for georeferencing. We need to enter these values one by one to complete the georeferencing process. Zoom in to the maximum level to view the corner. Enter the longitude value first. When entering the values, the first 2 digits represent the degrees, and after a space, enter the minutes. Similarly, enter the latitude value in the second line. Press OK to assign the values entered. Move to the next corner and repeat the same. Carefully enter the coordinates for all the corners, ensuring minimal error when locating the corner points. After entering the values, go to the Settings and enter the name of the output file you wish to save. Now run the georeferencer to finish the georeferencing process. Reopen the QGIS and load the georeferenced file. If the map is correctly georeferenced, the coordinates will be displayed accurately. You can verify this by loading Google Maps as a base map. To do this, load it from the HCMJS menu. If it's not available, you can install it as a plugin. See the description for the link. To compare with Google Maps, drag the Google Maps layer below the georeferenced layer. Toggle the visibility to check for alignment. If everything is okay up to this point, we shall go forward with the second task, digitization of the water body. First step is to make a new shapefile layer. For that, go to Layers and Create .layer, and then New Shapefile. Click the Browse button next to File Name and choose the folder where you want to save the shapefile. Provide a name for the shapefile. Choose the geometry type of the shapefile. Then click Toggle Editing, and then click Add Polygon Feature Tool and start digitizing the layer by tracing over the map. It is important to make smoother polygon for better representation of the water body. Finally, right-click and enter the polygon ID as 1. At the end of the digitization, we need to save and stop the editing. Now we shall calculate the area of the water body. Right-click the polygon layer and open the attribute table. Start editing. Select the new field. In the dialog box, give the name as area. This will create a column called area in the attribute table. Then open the field calculator. Click on the geometry and double-click on the $area. Check the Update Existing field and select the area. This will populate the area of the polygon in the attribute table. Save and stop editing the table. This marks end of the task 2. It is always a better idea to save your project in the same folder with your datasets. It is always advised to save the shape files also in the same folder. Now we will do the task 3, thresholding of the given satellite image. We will open the satellite image in the same way we did for the OSM map. Zoom in on the water body where you will perform thresholding. Adjust the zoom so that the entire extent of the water body fits exactly on the canvas. Next step is to make a subset of the water body. Go to the raster and then to extraction. We can choose Clip Raster by Extent. This will allow us to get a clipped image containing only the water body and the surrounding features visible on the canvas. Save the file as clipped water body in the data folder. Remove the previous image layer to see the clipped image properly. Open the property of the clipped layer by right-clicking the layer. Then select the histogram. Then click Compute Histogram. This will probably display a bimodal histogram. The left mode represents the pixels of the water body, while the right mode displays the pixels of the land. We shall choose a pixel value in between the land and water body pixels to execute thresholding. By visual analysis, we will choose the threshold value as 7,000 here. Go to Raster and then to Raster Calculator. Then select the clipped water body. The layer will appear in the Raster Calculator expression window. Give the expression as clipped water body greater than 7,000. Give a proper name to the output file and run the calculator. You will get a binary image highlighting the water body in black pixels. Now we will proceed with task 4, which is the digitization or vectorization of the binary image. We shall make a new polygon shapefile layer for that by using the Create Layer option. The procedure remains the same as in the case of digitizing on the OSM map. Select the layer, toggle editing, and start tracing the extent of the water body. Though it is difficult to make a smooth polygon, maximum care should be taken to get a realistic output. Follow the previously explained method to find the area of the newly drawn polygon. The procedure for creating a new column to display the area and the use of the raster calculator remains the same as in the case of the OSM map. Task 5 is to read carefully the evaluation sheet and submit the answers and requested files. Make sure that you submit all associated files of the shapefiles. As a part of evaluation for Task 1, you have to submit the georeferenced OSM map for evaluation. This can be submitted as a Google Drive link in the evaluation sheet against Task 1. For the Task 2 evaluation, you need to gather all associated files of the created shapefile SHP, SHX, PRJ, DBF, etc., zip them, and upload the zipped folder to Google Drive. Paste the link in the evaluation sheet, ensuring that the link is accessible for evaluation by granting the necessary permissions. For evaluation of the Task 3, you need to upload the subset to TIFF image and the thresholded binary images to Google Drive and paste the links in the evaluation sheet. Ensure that the links are accessible to the evaluator by granting the necessary permissions. For evaluation of the Task 4, gather all associated files .shp, .shx, .prjf, etc., zip them, and upload the zipped folder to Google Drive. Paste the link in the evaluation sheet, ensuring access by granting the necessary permissions. The final task is to answer a set of questions. This task will be evaluated only if all tasks up to Task 4 are completed.